If you read wartime letters from soldiers in Europe or study quartermaster reports from the early years of the Second World War, a quiet pattern emerges. Men complain constantly about cold, damp and exhaustion, but far less often about a lack of blankets. That omission matters because by 1942, military planners had already learned something civilians largely missed for decades afterward. Cotton blankets, no matter how thick, were a poor solution for real cold. What replaced them was not a single item, but a fibre system that changed how warmth was preserved in the field. And it performed so well that its principles still shape modern cold-weather gear. The problem with cotton was brutally simple. It absorbed moisture, lost insulation when wet, dried slowly, and compressed under weight. In trench warfare, shipboard duty, and long marches through rain and snow, cotton became a liability. Wet cotton pulled heat away from the body faster than bare skin. Early war casualty data showed that exposure and hypothermia were aggravated by traditional bedding and clothing choices. The response was not thicker blankets, but a complete rethinking of insulation. The fibre layer that outperformed cotton was wool-based insulation combined with lofted layering, often reinforced with early synthetic blends and felted construction. This, you see, was not ordinary civilian wool cloth. Military wool was processed to maximize crimp, elasticity and air retention. The goal was not weight or softness, but really trapped air. Air, not fabric, was the true insulator, and wool held it better than cotton under every condition that mattered in combat. Wool fibres have a natural three-dimensional structure. Each strand curls and springs back when compressed, maintaining loft even when damp. Unlike cotton, wool can absorb moisture vapour without feeling wet, allowing sweat to move away from the skin while preserving warmth. This mattered enormously in cold, wet theatres like Italy, Northwest Europe and the North Atlantic. Soldiers wrapped in wool layers stayed warmer even when soaked, while cotton blankets turned into cold sponges. The military did not rely on a single wool blanket to solve the problem. Instead, they adopted a layered fibre system. Wool underwear, wool shirts, wool trousers and wool field blankets worked together. Sleeping systems combined wool blankets with ground insulation and outer shells, reducing heat loss from below and blocking wind from above. The effectiveness came from the interaction of layers, not any one piece. Felted wool played a critical role. Felt is made by matting wool fibres together using moisture, heat and pressure. This process creates a dense but breathable material that resists wind penetration while still insulating. Felt boot liners, sleeping pads and inner liners were widely used because they performed even when crushed or damp. Cotton equivalents failed rapidly under the same conditions. By mid-war, some Allied forces began experimenting with blended fibres, mixing wool with early rayon or synthetic binders. These blends improved durability and reduced weight, while, still preserving insulation. Even so, pure wool remained the benchmark. Quartermaster evaluations consistently rated wool superior in cold, wet environments, and supply officers prioritised it despite, well, higher costs and logistical challenges. Applying this knowledge today starts with abandoning the idea that warmth equals thickness. A heavy cotton blanket may feel substantial, but it does little once moisture enters the system. So, the first practical step is choosing materials that retain their loft even when they're damp. Wool blankets, wool liners, and felted pads. They still outperform cotton for sleeping and static warmth, especially outdoors. The second step, well, it's layering rather than stacking. Instead of just one thick blanket, use multiple wool layers separated by air gaps. A wool base layer, a wool or felt mid-layer, and of course a wind-resistant outer shell. This creates a system that's quite similar to those old World War II sleeping arrangements. Ground insulation is the third lesson, and it's one that's often overlooked, honestly. World War II field manuals emphasised insulating from below just as much as from above. A wool or felt pad beneath the body, you see, prevents conductive heat loss into the ground, which is, more often than not, the greatest source of cold stress. Modern users can replicate this with felt rugs, wool blankets folded beneath sleeping mats, or layered natural materials. Moisture management is the fourth critical factor. Wool works best when paired with ventilation. Avoid sealing wool inside impermeable plastic. World War II systems allowed moisture vapour to escape, preventing condensation build-up. In practice, this means using breathable outer layers and, periodically airing out wool items when conditions allow. What made this fibre system revolutionary was not technology, but, understanding. Military planners stopped treating warmth as a static object and started treating it as a process. Control moisture, preserve loft, manage airflow, and insulate from the ground. Cotton failed because it violated every one of these principles under real conditions. This knowledge did not disappear after the war. It became the foundation of modern cold weather doctrine, from mountaineering to polar exploration. The language changed, but the physics did not. Synthetic insulation tries to mimic what wool already did naturally, and honestly, it often still falls short in wet environments. If you value historical knowledge that translates directly into practical survival wisdom, well, this is the kind of content this channel exists to explore. Subscribe to stay connected to research-driven stories that go beyond surface history, and share this episode with anyone still relying on cotton when the weather turns serious.